Hello and welcome back. In this video we'll finish up section 4.1. And when we looked at graphing the cosines and sines when we had some extra numbers in there, we saw that those numbers were really affecting the amplitude and the wavelength. So here when we took the cosine of 1/2 theta, our wavelength essentially doubled. So we could only fit a half of the wavelength in where the usual wavelength would be. When we looked at the graph of sine of 3 theta, our wavelength shrunk a lot. And in fact, it shrunk so much that we could fit 3 wavelengths in, where we could only fit 1 before. And the easier examples were when we multiplied our sine and cosine by a number, which essentially just affected the amplitude of our function. So to summarize this, we have the following statement here. This is very important and is probably the most important thing in this section. So for a sine b theta and a cosine b theta, so we have two places that we can add a number. We can either add a number out front, which we said affected the amplitude, or we can add a number sort of inside the function, which affects the angles that we're plugging in. So that's going to affect the period. We have a formula for what happens to the amplitude and the period of the function. So here, the amplitude is just going to be the absolute value of a. So for instance, if I put a 2 out here, if I looked at 2 sine theta, our amplitude is going to double up to 2. If I put a 1/2 up here, 1/2 times sine theta, our amplitude is going to shrink by a half. And the reason I have to take the absolute value is, if it's negative, the amplitude is still going to shrink or grow, but the whole function is going to flip over, because all the positive values are now negative, all the negative values are all positive. So we want to take the absolute value here. Also, the period of the function, this is maybe a little bit counterintuitive, but the period is going to be 2 pi divided by b. 2 pi is the usual period, and it gets divided by b when we want to figure it out. So let's go through our examples up here and calculate what happens to their amplitude and period. So let me just abbreviate. So the amplitude and the period. So the amplitude, I have 2 sine theta, and I can just think of this as 1 times theta. So this is going to be 2, so the amplitude is going to be the absolute value of 2, which is 2. And we can see that. We go up 2 and we come down 2, so our amplitude is indeed 2. Okay, so that's easy to see. Our period is going to be 2 pi divided by b, and b is the number that's multiplying this theta here. Well, that's just 1. So our period is still 2 pi. That hasn't changed. Sine theta has a period of 2 pi. That hasn't changed in this function. Cool. Let's look at the graph of 1/2 cosine theta. So the period, I should start with the amplitude. The amplitude and the period of this function. So the amplitude, using our formula, should be the absolute value of -1/2, and that is -1/2. So let's check. Does that make sense? Well, the distance from the middle of our function to the highest point it reaches, and the distance from our function to the lowest point it reaches, are 1/2. It only goes up a half and down a half. So the amplitude is in fact 1/2. So that makes sense. The period of our function should be 2 pi divided by b, and in this case b, the number that's multiplying theta, is 1. So the period is 2 pi. That makes sense. Nothing has changed. We still we can see that the wavelength, the period of our function from, let's say, the lowest point to the lowest point, that is still 2 pi log. So the period is still 2 pi. That makes sense. Now let's look at the graph of sine of 3 theta. and I'm going to erase some of the work that we did over here so that I have some room to write. So let's look at the amplitude and the period of the function. Well, we're not multiplying this by anything. The height of the function is always still 1 at the most, -1 at the least. So the amplitude, the distance from the center to the top, is still 1, which, if I think about it, this is just 1 times the sine of 3 theta. So the amplitude is still 1. The period, on the other hand, we said that, okay, the period of sine theta is 2 pi, but we fit 3 periods in here. We fit 3 wavelengths in here in the span that we would normally fit 1. So the period is 2 pi, and then we've cut it into thirds, which is 3, which is a formula that we have. 2 pi divided by b, and this is our period. So it's just a rather nice formula. And then let's do the same thing here. So I'll erase some of this extra work that we don't need anymore. So if we look at the amplitude and the period of this function, again, the amplitude, the distance from the center of our function, the highest it gets and the lowest it gets, well, again, the amplitude is just 1. This is 1 cosine theta, so the absolute value of 1 is 1. The period, on the other hand, we can see that our period has essentially doubled. When we would normally fit 1 wavelength, 1 period in, we can only fit half of it in anymore. So if we use our formula, we'll take 2 pi divided by a half. Well, how do you divide something by a half? It's like this, it's the same thing as multiplying it by 2. So our period is now 4 pi, which is double what it was before. And this makes sense. We saw that our cosine wave is really stretched out, so our period is now longer than it was before. So the amplitude and period, we just have these nice handy formulas that will describe this. The amplitude is what we're multiplying by out front, and the amplitude is the distance, so we've always wanted it to be positive, so we'll just take the absolute value of it. The period is going to be 2 pi divided by b, so if b is, say, less than 1, our amplitude or our period is going to grow. If b is bigger than 1, our period is going to shrink down. Oops. I apologize. I messed up my recorder for just a second. So we can calculate amplitude and period pretty easily just from the numbers in our function. So now let's work backwards. Now I'll give us some graphs, and we have to work out, is it going to be a sine function, or is it going to be a cosine function? And if so, what are a and b going to be? So we'll have to look at our function, determine, is it a sine function, cosine function? We'll find the amplitude, and we'll find the period, and that should give us everything we need. So here, let's look to see what our function looks like. Well, we're starting up here at 3, and we're falling down right away. So the difference between the sine and the cosine function, the sine should always start at 0, and the cosine function does not. So here we're starting, this looks like a cosine function. At 0, we're starting at a number that's not 0. So this is going to be cosine. So this is the first thing. It's not going to be sine because it doesn't start at 0. Next, let's find a. A should be our amplitude, right? So what we'll notice is that the cosine of 0 should be 1. That's where we should be starting at. But we've grown up to 3. So to get from 1 to 3, that's a factor of 3 there. So a here is going to be 3. And again, we can see that the amplitude of our function is going to be 3. The amplitude of our function is 3. So a should be 3 or -3, but since we're going from 1 up to 3, we know that we're going to be positive 3. And now for b, and I think b is maybe the trickiest one, but it's not too bad. We need to find the wavelength of our function, and then we can figure out what b is. So the wavelength, if we look at where we start, that's the top of a crest, top of a wave, and we'll come back and we see that we hit the top of the wave over here. So 4 is going to be our wavelength, or our period. So if we think about it though, we know that the formula for the period is going to be 2 pi divided by b. So 4 is going to equal to 2 pi divided by b. And if I solve for b, what I get is that b is going to be pi divided by 2. Multiply both sides by b, divide both sides by 4, and here's our answer. So we know that a is 3, since we're stretching our cosine function by a factor of 3. B is going to be pi divided by 2, since we have our formula for the period of a trig function, of our sine or cosine. So our function here is going to be 3 times the cosine of pi over 2 times theta. So this is our function. It's fairly straightforward. Just identify, if we're looking at a sine or cosine, identify the amplitude, which will be our value for a, and identify the period, which helps us find what b is. Let's do one more example of this. So we need to find the function. Is this going to be a sine b theta, or is it going to be a cosine b theta? So let's look at the difference between sine and cosine. Sine always starts at 0 and should go up. Cosine should start at 1 and go down. And what we'll notice is that we're starting at 0 here. So starting at 0 means that we're not cosine and that we are sine. So this is great. And then the only troubling thing though is that our sine function is going down, when normally our sine function should go up. So this is what we think that a sine function should do, is it should go up right away, but it's going down. What's the difference between going to a positive number and going to a negative number? Well, we've multiplied by some negative number. So because we're going down, we know that a is negative. Again, instead of becoming a positive number, we're becoming negative right away. So we know that a is negative. But we can also find the amplitude of our function. So the amplitude, again, is the distance from the center of our function to the highest and lowest points. Well, if here is 1, and there's negative 1, that means that we're coming up to a half at the highest and down to negative a half at the lowest. So the amplitude of our function, which is the absolute value of a, the amplitude is 1/2. So we know 2 facts. We know that a is negative, and we know that the absolute value of a is 1/2. So that means that a should be negative 1/2. Again, the amplitude of our function is a half, but because we go down, it has to be a negative number. And then the last thing to do is to look at our wavelength. So here, or our period. So we're starting at 0 and we're going down. Here's the next place that we start at 0 and go down. So here is our period. We have one dip and then one hump. So one dip, one hump, and then one dip, one hump. So here is our period, which is going to be 4 pi. So we know that the period of a function is always going to be equal to 2 pi divided by b. And if I solve for b here, multiply both sides by b, divide both sides by 4 pi, we get 1/2. And there we go. Now I can put everything together. So I've got sine, I've got negative 1/2 sine of 1/2 theta. And there's our function. We just look at the amplitude and the wavelength and decide whether it's cosine or sine.